So this evening we're going to look at how to come up with some equations which we can use to actually describe the projectile motion which we started looking at last week. Okay. And also this is going to be the last topic in this section. Then so that the next time we meet tomorrow we'll start looking at Newton's laws of motion, and we move forward like that until so we just keep on making progress until we reach wherever we're supposed to reach. So in this lecture we are interested in a couple of things. We want to describe projectile motion in terms of the physical quantities which we looked at. For example, in terms of how much time it takes your projectile to reach to maximum height. That is something which people are always interested in when it comes to projectiles. People are also always interested in the maximum height which was reached by a projectile. So we also want to be able to do that. How do you find that quickly? We also want to find out the time it takes a projectile to fall from maximum height. Okay, the time it takes a projectile to fall from maximum height. So we also want to find that. So how much time does it take a projectile to come down from maximum height up to the ground? Then the other thing we are interested in is something called flight time. This is the time the projectile is in the air. How much time, for how long is the projectile in the air? That's what we're interested in. And the other thing we're interested in is how far does the projectile travel along the horizontal direction. That is the range. Now the range is related to the flight time, as we are going to see. So the more time something is flying, that means that directly translates to the more distance that particular object which is flying or projectile is going to move or cover. Okay, that's the range. And we want to find out how you would predict with what velocity a projectile is going to strike the ground. So basically these are objectives. We want a formula for rise time. We want a formula for maximum height. We want a formula for fall time. We also want a formula for flight time. Then we want a formula for range, for projectile, and we want to find out the velocity with which the projectile is actually going to strike the ground. Okay. So, in our lesson, we are going to make things a bit more general and less specific than what we did last time. So last time our velocity with which a projectile was launched in the air was 550 meters per second. So in this case, we're not going to do that, but we're just going to say that our velocity of our projectile, the initial launch velocity of our projectile is u. That's the initial velocity, and it is fired from the ground at an angle of theta with respect to the ground. So these are the pieces of information we have. We know the initial velocity, which is u, and we also know the angle at which this projectile is fired from the ground. So with this information, we want to find how much time does it take to reach maximum height, what is the maximum height the projectile reaches, what is the fall time, what is the flight time, and the range. Okay, so before we proceed, you have to recognize a few things about the projectile. That any projectile moves in two different directions. It moves horizontally, so it covers distance horizontally, but it also moves physically. It also moves vertically in the vertical direction, and this movement, horizontal movement and vertical movements, they happen at the same time. So that's the thing which you need to recognize, that the vertical and the horizontal movements of a projectile do happen at the same time. So it's very, very important that you recognize this. The thing also you should note is that the horizontal motion of a projectile, there is no acceleration in the horizontal direction. So basically, the projectile moves in the horizontal direction at constant velocity, while in the vertical direction, the acceleration is present. Because in the vertical direction, your projectile needs to reach maximum height, and when it reaches maximum height, the velocity is going to be 0. Since the velocity at maximum height is equal to 0 meters per second, and this projectile in the vertical direction was launched with some particular value of velocity, it means that the velocity changed during the time it was traveling to maximum height. So that shows that acceleration is present in the vertical direction. Also, when your projectile is coming back from maximum height, it's going to experience an increase in velocity as it approaches the ground. So there is acceleration in the vertical direction, but there is no acceleration in the horizontal direction. Okay, the acceleration in the vertical direction has a size of 9.8 meters per second. So that is the acceleration in the vertical direction, 9.8 meters per second. Then if your projectile is moving away from the surface of the earth, we know that the acceleration is minus 9.8 meters per second. Then if it's moving towards the surface of the earth, coming back from maximum height, we know that the acceleration is plus 9.8 meters per second. The acceleration is only in the vertical direction. So given a value of launch velocity, u, the first thing we want to do is we want to find out how much is the launch velocity along the horizontal direction or along the x-axis, and how much is the launch velocity along the vertical direction or the y-axis. So we need to decompose, or we need to break down our launch velocity, which is a vector, into its components, into its x and y components. These x and y components of the launch velocity will give us the how much is the velocity in the x direction and how much is the velocity in the y direction. Once we have the how much is the velocity along the x direction and how much is the velocity along the y direction, then you recognize that along the horizontal direction there is no acceleration. So the velocity along the horizontal direction is the same as whatever the component is. So the final velocity in the x direction, the final velocity after your projectile has flown in the x direction is going to be the same as the initial velocity in the x direction. In the y direction, of course, there's going to be a change in velocity since your projectile needs to get to maximum height, and that means it has to reduce in speed until it has a velocity of 0. Then from maximum height it has to come down from there, and that means that the velocity has to increase. So at one point when your projectile is going up in the y direction, the acceleration is minus 9.8 meters per second. At the other point when your thing is coming down, the acceleration is plus 9.8 meters per second. So after we find out how much the components are of the velocity, we are going to focus only on what's happening in the y direction, because that's where the interesting thing is happening. That's where the acceleration is. In the x direction, there's nothing interesting happening because there is no acceleration. The velocity is the same. So you can always predict at any point in time how much the velocity in the x direction is, because it is constant. The reason why it's constant is because there's no acceleration. So our focus, after we decompose, we find out how much the launch velocity is along the x-axis and how much it is along the y-axis. Our focus will be on finding out how much time does it take your projectile to reach maximum height. That's what we're calling the rise time. And what is the actual maximum height reached by the projectile? That's what we are calling the maximum height. We will also be interested in finding out how much time does it take your projectile to fall from maximum height, and what is the amount of time the projectile was actually in the air, which is called the flight time. After that, our interest will be in finding out with what velocity the projectile is going to strike the ground in the vertical direction. Okay? Once we have answered these questions, the rise time, the maximum height reached by the projectile, the fall time, the flight time, and the strike velocity in the vertical direction, then we are going to turn our attention to item number 4, where we're going to try to work out the range based on the velocity of the projectile in the x direction and the flight time. Then once I've done that, then we're going to work out item number 5, the strike velocity with which the projectile actually strikes the ground. So the first item from here is decomposition. We know and recognize that the launch velocity is a vector, therefore we are interested in finding out how much the velocity is along the x direction and how much it is along the y direction. So if your projectile is launched in the air with the velocity u at an angle theta, you can easily find out how much the velocity is along the x-axis as follows. Ux is equals to u cos theta, and uy along the y direction is equals to u sin theta. So these components, ux and uy, they give you the how much your launch velocity u launched at an angle theta is along the x direction or the horizontal direction and along the y direction, which is the vertical direction. So along the x direction, your velocity is ux, and that is u cos theta. Along the y direction, your initial launch velocity is uy, which is equals to u sin theta. So the how much has been answered. This ux along the x direction will not change, because along the x direction we do not have any acceleration. So along the x direction, ux will remain unchanged throughout this whole time this projectile is going to maximum height and coming back. However, along the y direction, this uy, the velocity of the projectile in the y direction, will change, because this projectile in the y direction will have to reach maximum height. When something reaches maximum height, the velocity of that particular something at maximum height is equals to 0. So this u sin theta will have to decrease from whatever it is u sin theta to a value of 0, a final velocity vy at maximum height of 0 meters per second, and the rate at which it's going to decrease is your acceleration due to gravity of minus 9.8 meters per second. So that's the thing here. Okay, so we have done the decomposition part. So next we are interested in finding out the rise time. Now, in the y direction, the initial velocity in the y direction is what we have here, u sin theta. Then the final velocity when this projectile moving in the y direction reaches maximum height, the final velocity in the y direction is going to be 0 meters per second, because at maximum height your projectile will have a velocity of 0 meters per second. So the initial velocity is uy, which is u sin theta. Then since your projectile is moving away from the surface of the earth, its velocity will reduce at a rate of minus 9.8 meters per second squared. So the acceleration due to gravity will be negative in this case. G is going to be minus 9.8 meters per second squared. When it reaches maximum height, and how are we going to know that we're at maximum height? The velocity at maximum height of your projectile is going to be equals to 0 meters per second. So Vy at maximum height is going to be 0 meters per second. That's how we are going to know. So Vy, so we can use this formula, Vy, which is the velocity at maximum height, is equals to Uy, which is the velocity in the y direction, initial velocity in the y direction, Uy plus G, then the time it's going to take to reach maximum height. That's what you're going to rise. When you make substitutions for Vy, so Vy is going to be 0 meters per second, then plus Uy, which is equals to u sin theta, then plus G, which is minus 9.8 meters per second. Now, we know that the actual size of the acceleration, whether you're going up or coming down, is actually 9.8 meters per second. It just happens that when you're going up, your 9.8 meters per second is negative, and when you're coming back, the 9.8 meters per second is positive. So instead of writing minus 9.8 meters per second, we actually use minus g as our acceleration due to gravity, because we know the value of g, which is 9.8 meters per second here. So when you multiply, when you drop off your units, in this case 0.8 meters per second, and also when you multiply this plus and that minus, so you end up with 0 equals to u sine theta minus g t rise. Then you get this minus g t rise to the other side, you end up with g t rise equals to u sine theta. Then you divide both sides by g, you end up with t rise is equals to u sine theta divided by g. So with this expression, t rise equals to u sine theta divided by g, this is how you work out the amount of time it's going to take your projectile to reach maximum height. As you can see, the amount of time depends on the velocity with which your projectile is fired. It also depends on the angle at which your projectile is fired, and since we are on Earth and you're not leaving Earth anytime soon, it depends on g, which is 9.8 meters per second. Do we have any questions on this expression? How we have come up with this expression and what it is actually used for? T rise is equals to u sine theta divided by g. Are we clear on this expression?
Yes, sir.
Okay. Next, the next thing we want to find out is the maximum height. How high did this projectile actually go in this amount of time t rise? So we know the amount of time it took, which is u sine theta divided by g, and we know with this information we can work out. We also know the initial velocity with which the projectile went up. So you can work out the maximum height the projectile went to using this expression. S max, which is maximum height, is equals to the initial velocity in the y direction multiplied by the time it took to reach maximum height, which is t rise. We have found t rise plus half, then g t rise squared. Our g in this case is minus 9.8 meters per second. So instead of writing g, we're going to write minus g, and we're going to replace this uy with what we have as the component, and we're also going to replace t rise with the value of t rise we have found. So when you do that, we know that uy is u sine theta, which is what we have here. Then t rise is u sine theta divided by g, then plus half. Our g, we're going up, is negative, so it's minus g. Then t rise squared, which is going to be u sine theta divided by g squared, like that. When you multiply this times this, so you end up with u squared sine squared theta divided by g. This other side you end up with minus g over 2. Then you have got u squared sine squared theta divided by g squared at the bottom there. So here you end up, this is what you end up with. S max is equals to u squared sine squared theta divided by g minus g over 2, then u squared sine squared theta divided by g squared. The g here on top, and this one of the g's at the bottom here, they cancel out. So instead of having 2g, you end up with just a g there. So you end up with this side, you end up with u squared sine squared theta divided by g, then minus u squared sine squared theta divided by 2g this side. The common denominator here, so there's a g here, there's 2g, so the common denominator is 2g. That's what we end up having there. So this g goes into 2g 2 times, then that 2 times we multiply it with this, you end up with 2 u squared sine squared theta, which is what you have here. Then this 2g goes into 2g once, so that one multiplied by this, so you end up with u squared sine squared theta on top here. Then 2 u squared theta sine squared theta minus u squared sine squared theta. So this whole thing, this expression here, this is the same as this. So if you're doing your mathematics, you'd probably just do like 2x minus x, so that would give you x. So in this case, when you do 2 u squared sine squared theta minus your u squared sine squared theta, so we end up with only u squared sine squared theta divided by 2g. So this expression, S max is equals to u squared sine squared theta divided by 2g, gives us a formula for working out the maximum height. Again, the maximum height depends only on the velocity with which the projectile is thrown up in the air. It also depends only on the angle at which the projectile is fired. This g does not change because, like I've said, people are not leaving Earth anytime soon. Okay. Any questions on how you work out the maximum height? Is this clear on how you work out the maximum height of a projectile?
So where do the 2g's come from?
Sorry?
Those 2g's in the equation. Where do we include them?
The what?
The g and the g in the equation. U squared sine squared theta over g, and the 1 minus g over 2, open brackets, u squared sine theta over g squared. Those 2g's.
This?
Yes, and then the other one.
And which one? This g?
Yeah, why do you have 2g's in the equation?
Here. You multiply this u sine theta multiplied by u sine theta, then divide by g. So you end up with u squared sine squared theta divided by g. Then here you have half, then minus g, then this u sine squared theta divided by g. Remember, in this formula you've got t squared. So in our case, our t is t rise squared, and our t rise is this value here. This is our t rise. The time it takes your projectile to reach maximum height. So when you square this, you end up with u squared sine squared theta divided by g squared, which is what you have here. So this is your rise time squared. Then there is a g here. You're doing a multiplication, g times this. So you're going to cancel one of the g's. Then there's a 2 here, which is going to multiply the g at the bottom. So you end up with 2g here. Then you make the common denominator here between g and 2g is 2g. So this g goes into 2g 2 times. Then you multiply times this. So you end up with 2u squared sine squared theta. Then this 2g goes into 2g once. Then you multiply by this, you end up with minus u squared sine squared theta. Then this 2u squared sine squared theta minus u squared sine squared theta is just u squared sine squared theta. Then divide by this 2g here. Is this clear?
Yes, all right.
Okay. So we know, with up to this point, we know 2 things. We know the rise time, how much time it takes your projectile to reach maximum height. We also know the maximum height reached by the projectile. Okay. Now, if the projectile is going to come back from maximum height back to the ground, you would logically assume that it is going to travel through the same amount of distance it took to maximum height. Okay, because a projectile normally does not somehow hang in the air, it covers the whole distance. So if this is a distance to maximum height, when the projectile comes back from maximum height, this is the same amount of distance it will cover. So we can use this amount of distance to try to find out how much time it will take your projectile to fall from maximum height. At the same time, you also know something about the velocity of the projectile in the y direction at maximum height. You know that at maximum height, the velocity of your projectile is equals to 0 meters per second. That's why it's called maximum height, because the projectile is 0 meters per second at that particular point. Okay. So we know the velocity of the projectile at maximum height is 0 meters per second. We know that it's going to be moving from maximum height towards the earth. Therefore, the velocity is going to be increasing. So there's acceleration. And if an object is accelerating towards the surface of the earth, then the acceleration is 9.8 meters per second. Okay, positive. And we assume that this thing is not going to land on a mountain, but it's going to fall all the way down to the earth, okay, to the ground. So we can use this expression, S max, which is the maximum height, is equal to the initial velocity. Now we are starting from maximum height coming down, multiplied by the 4 time. The time is going to take your thing to 4, plus half, then g t4 squared. This 4 times squared. Now at maximum height, the maximum height or the maximum distance through which your projectile is going to fall is what you have found here as S max. So this is going to be u squared sin squared theta divided by 2g equals to the velocity of your projectile at maximum height, initial velocity at maximum height, which is 0 meters per second, multiplied by the 4 time. The time is going to take to 4. That's what you're looking for. So it's t4. Then plus half times g. The g is, this case, it's positive, so we just write g multiplied by the 4 time. This 0 times t4 time is just going to give you 0 here. So you end up with u squared sin squared theta divided by 2g plus half g t squared 4. So you end up with this u squared sin squared theta divided by 2g equals to half g t squared. So this is supposed to be actually t4 squared. I wrote a 2 there, so t4 squared. So in the next series of notes, this will have to be changed there. Next, there is a 2 this side, there's a 2 at the bottom there, there's a 2 at the bottom here, so that constitutes half. So you can cancel out the halves. When you cancel out the halves, you end up with u squared sin squared theta divided by g equals to g, then t squared sin squared t squared 4. Then on both sides, you divide by g. When you divide by g on both sides, so this side, if you divide by g, so it's going to be g t4 squared divided by g. This side, you also divide by g. So you're doing the same thing on both sides. So you're going to end up with t4 squared equals to u squared sin squared theta divided by g squared. Then when you square root on both sides, you end up with a square root on both sides. So you end up with t4 is equals to u sin theta divided by g. So this gives you an expression for the 4 time, saying the 4 time is going to be equals to u sin theta divided by g. This 4 time equals to u sin theta divided by g is the same as this rise time, u sin theta divided by g. The reason why it's the same is because, first and foremost, the distance to which they go to is the same, and also the acceleration is the same. Yes, there's a difference in sign of the acceleration, but the magnitude of the acceleration is actually the same. It's 9.8 meters per second. It's just that the negative sign tells you you're going away from the surface of the earth, and therefore your acceleration is going to result in a slowdown, in a reduction in velocity. And if you're moving towards the surface of the earth, your acceleration is positive, and therefore that's going to result in an increase in velocity. So you can see that the 4 time in this case is the same as the rise time. So the rise time and the 4 time in this case are the same, which is equal to u sin theta divided by g. The reason why this is the case is because the height through which a projectile rises and falls happens to be the same. Are we clear?
Yes, sir.
Okay. The next thing you want to work out after working out your 4 time is you want to work out how much time does it take your projectile to fly in the air. The how much time your projectile flies in the air is something called flight time. This flight time is equal to the sum of the rise time, the time it takes your projectile to rise to maximum height, plus the time it takes your projectile to fall from maximum height. So your flight time TF is equal to rise time plus 4 time. Your rise time you have found is equal to u sin theta divided by g plus your 4 time, which is equal to u sin theta divided by g. So if you add these, you end up with the flight time TF, which is equal to u sin theta divided by 2 u sin theta divided by g. So TF is equals to, basically you can say, depending on what you want, the flight time is equals to u sin theta divided by g, which you can rewrite as 2 t rise, twice the rise time or twice the 4 time, depending on which one is easier for you. So this is how you get the flight time. Again, the flight time depends only on the velocity of the projectile and also the angle at which the projectile is fired. There is no connection whatsoever to the mass of the projectile. The mass, how big something is, does not affect how far it is going to go or how long it's going to be in the air. How long a projectile is going to be in the air totally depends on the velocity with which the projectile is shot in the air and the angle at which the projectile is fired. Is this clear? Are we clear on this? Are there any questions? Any questions?
Yes, I disagree.
Okay. The next thing we're interested in is what is the velocity with which your projectile strikes the ground in the y direction? With what velocity does your projectile strike the ground in the y direction? Now remember, in the y direction where your projectile is coming from, your projectile is coming from maximum height. At maximum height, the initial velocity at maximum height, or the velocity at maximum height, is 0 meters per second. However, your projectile, when it hits the ground, its velocity would not be equal to 0 meters per second because its velocity would have increased. And the reason why your velocity increases is because as your projectile approaches the surface of the earth, its velocity increases at a rate of 9.8 meters per second every second. That's why I'm saying G is here is 9.8 meters per second. So the velocity, your projectile, when it hits the ground, will have a velocity which is greater than 0. However, that also depends on for how long this thing is going to fall. So we use this expression, V is equal to U plus GT. V for our final velocity when your projectile strikes the ground in the y direction, then U for the initial velocity, then G for the acceleration, then T for the fall time. So when we consider only in the y direction, we end up having Vy, which is the velocity of the projectile in the y direction as it strikes the ground, will be equals to Uy, the initial velocity of the projectile at maximum height, plus G, which is acceleration due to gravity, multiplied by the fall time, which is the time it takes your projectile to fall. So in our case, your initial velocity at maximum height is 0 meters per second. We have an expression for fall time, which is U sine theta divided by G, and we are falling towards the surface of the earth. So Vy is going to be equals to 0 meters per second plus G, then U sine theta divided by G. So in this case, G divided by G, that's going to give you 1. You cancel out the G times that. There's G on top, there's G at the bottom, like that. So you remain with U sine theta. So this is 0 plus U sine theta. So in this case, you end up Vy is equal to 0 plus U sine theta like this. Then Vy is going to be equal to U sine theta. So this is the velocity with which your projectile hits the ground in the y direction. So Vy is equal to U sine theta. Now, the thing about this U sine theta is that this U sine theta is actually the same as the initial velocity of your projectile in the y direction. When your projectile was going up in the y direction, its velocity it started with in the y direction was equal to Uy is equal to U sine theta. So when it comes back from wherever it has gone and hits the ground, it's going to hit the ground with the same velocity with which it went up. So Vy is going to be equal to U sine theta. So our conclusion is that the velocity with which a projectile goes up is the same as the velocity with which the projectile is going to strike the ground, as long as the time it takes the projectile to go up and come down is the same. The time it takes the projectile to go up and come down depends on the height which the projectile covered. So if the height to go up and the height to come down are the same, then a couple of things are going to be the same. If the height to go up is the same as the height to come down, then 1, the time to rise to maximum height and the time to fall maximum height will be the same. So rise time will be equal to 4 time. The other thing which is going to be the same is the velocity. The initial velocity in the y direction going up and the initial velocity in the y direction with which the projectile hits the ground will be the same. So Vy is going to be equal to u sine theta, like this. Are we clear? This is just a velocity in the y direction. So, but at the time the velocity projectile hits the ground in the y direction, its velocity is going to be u sine theta. Are we clear? Next, we want to find out how long the projectile is going to move in the horizontal direction, which is what is called the range. Now remember, in the horizontal direction, the velocity does not change. So the velocity is constant. It's still ux at any point in time. The velocity in the y direction, in the x direction or the horizontal direction is ux. So for us to find the distance which the projectile moves in the horizontal direction, we need to multiply ux times the flight time. The ux is the same, it doesn't change. We need to multiply this ux, which is equals to, in this table, ux is equals to, here, ux is equals to u cos theta. So you need to multiply u cos theta multiplied by the flight time, which is 2u sin theta divided by g, our flight time. This is our flight time. So you need to multiply this flight time times ux, and that's what you're going to do. So this times that. So when you do that, our ux is u cos theta times our flight time, which is 2u sin theta divided by g. When you multiply this times this thing on top, you end up with the following. You end up with a 2, then there's this u multiplied by this u, you end up with u squared. Then there's this cos theta multiplied by this sin theta, you end up with cos theta sin theta. Then the whole thing divided by g. Then we factor out this u squared and this g, so we end up with range is equals to u squared divided by g. Then the remaining thing inside is going to be 2 cos theta sin theta. Now we are seeking for an expression which corresponds to this, which is much simpler. And what we are going to do is we turn to something called trigonometric identities, and especially this one, identity. So this identity is a compound trigonometric identity. So we say sine a plus b is equals to, actually it says sine a plus b is equals to sine a cos b plus sine b cos a. Now if we make a equals to b, so in that case we're going to have sine a plus a, which is the same as sine 2a. This is going to be equals to sine a. So where there's b, we put a, cos a plus sine a cos a. And this is going to be the same. This is the same, sine a cos a. Sine a cos a. That's going to give you 2 sine a cos a. So we have this 2 cos a, 2 sine a cos a. This 2 sine a cos a looks very similar to this 2 cos theta sine theta, except in our case, instead of a, we have theta. And yeah, so for this expression, if we replace the a with theta, so we end up with 2 sine theta cos theta, and that's going to be equals to this expression here, which is equals to 2a. So this 2a now is going to become sine 2 theta. So you end up with sine 2 theta equals to 2 sine theta cos a. So next we substitute for this in this expression here, and we put in sine 2 theta. So we end up having a range which is equals to u squared over g multiplied by sine theta, which just gives you range is equals to u squared sine 2 theta divided by g. So this is the expression you use to find out how long or how far in the horizontal direction your projectile is actually going to move forward. Is this clear on the expression for the range? Again, you only need to know the velocity with which a projectile is fired and the angle at which a projectile is fired. Is this clear?
Yes, sir.
Okay. Usually we are also very interested in a quantity called maximum range. Arabanks. We are usually interested in a quantity called maximum range. Now, for you to obtain this maximum range, you have to be aware that you are multiplying with a sign here. And the sign function has got a maximum value of +1, of 1. And this maximum value of sine of 1 only occurs when the angle, which this 2 theta is equals to 90 degrees. So when the angle of the sine is equals to 90 degrees, then your sine function gives you a value of 1, and that's the maximum value it can have. So if you want to obtain maximum range, then you better make sure that this part, sine 2 theta, is equals to 90. So if sine 2 theta is equals to 90, in this case, if sine 2 theta is equals to 90, then it means that theta is equals to 45 degrees. So if you want to obtain maximum range from a projectile, you need to fire your projectile at an angle of 45 degrees. When you fire a projectile at an angle of 45 degrees, this sine 2 theta is going to give you a value of 1. So you're only going to remain with u squared divided by g. So in this case, your maximum range only depends on your velocity squared divided by g. So if you've got a velocity, then you square it, then you divide by g. That gives you a maximum range, assuming that you are firing this projectile at an angle of 45 degrees. Are we clear?
Yes, sir.
Okay, any questions? We have come to the end of this lecture. Are there any questions? Okay, if there are no questions, the recorded video, as usual, we'll post it to the YouTube and post the link in the Moodle so that you can refer to it during the rest of the year and whenever you feel like rewatching the lecture. Okay, so I'll stop sharing if there are no questions. Yes.
Hello?
Yes.
Sir, I have a quick answer the quiz later. Are we supposed to include units on answering the quiz?
You are supposed to what?
Include the units
Where are you including the units?
when answering the quiz.
When answering the quiz.
Yeah, the quiz online. The online one.
Usually our quizzes are multiple choice. So where are you including the units?
There are some of the questions which requires us to fill in.
When was that?
The quiz.
The one you wrote today?
Yes.
Okay. I'm not sure, but usually fill-in questions bring complications. Yeah. So I'm not quite sure. You can put units, it's fine.
So when we tried to put unit, the answer was not submitted. It was sent, it was invalidated. So
It was what?
I don't know what invalidated. It was showing that it has not been submitted.
Yeah. Yeah, usually I'm not for these fill-in questions because one, students struggle to type properly how the units are supposed to be entered. So me, I'm for multiple choice questions really.
Okay, thank you, sir.
All right. Any other questions?
those notes on Moodle, sir?
Sorry?
The notes on projectile motion.
Yes, they are there on Moodle. They are there. That's where I got them from. All the notes we show you are there on Moodle. Okay, so if there are no other questions, we come to the end. See you tomorrow when you start looking at Newton's laws of motion. Okay, so I'll end here.